Good evening to our lecturer, Puan Hashamiza, and today I will doing an explanation for our essay one for the subject DEP563 wireless communication, and the question is expansion of operating frequency bands from 1G to 5G, environmental impact and sustainable spectrum management. And I and my partner Shah Jehan and me Wong De Wei will explain in this slide. And now get into the first slide, introduction. First we get the introduction from 1G to 5G. The mobile communication environment from 1G start from 1980 until analog voice until nowadays 5G in 2020 with the ultra-fast broadband. Each generation using high-frequency band to carry more data. For example, like 1G using 800 MHz, and nowadays the 5G using both sub 6 GHz and wave 26 until to 39 GHz. 5G can reach up to 20 gigs with frequencies as high as 100 millimeter wave. Increasing data demand, streaming, IoT, AI, cloud require broader and higher spectrum. However, higher frequency means denser infrastructure which impact energy and environment. In 5G, we can using the 100% faster speed and also high power consumption compare with uh, like previous generations. And the second, frequency bands. We are now our generation is start from 1G and 5G, and we start from 1G. 1G is released in 1980, and the frequency range is 800 to 900 megahertz, and the data rate is 2.4 kilobyte per second, and the technology is analog. For now, second, 2Gs. The 2G network is released in 1990 with frequency range 900 to 1080 MHz with data rate 64 GB per second and using GSM technologies. First now enter to the third generation released at 2000 century 2000 and using the frequency range 1.8 to 2.5 GHz with the 2 megabyte per second data rate and UMTS technology. For 4G, it released in 2010 using the frequency range 2 until 6 GHz with the 100 megabyte per second to 1 gigabyte per second data rate and using LTE technologies. Lastly, using the latest technology 5G released in 2020 with 6 gigahertz and 24 gigahertz to 100 gigahertz data rate up to 20 gigabyte per second and using technology NR new radio. Now enter to the third slide. How spectrum expansion supports data demands. In using a higher frequency, which means larger bandwidth, allowing more simultaneous user. Massive MIMO and bit volume improve efficiency of limit spectrum. Support IoT, autonomous vehicle, and smart cities that need low latency. Enables new application 8K streaming, VR, AR, remote healthcare. Like example, now we are knowing the device 5G is around 1 million kilometer per square. The 4G is 100,000 kilometer per square. 3G is 10 10,000 kilometer per square, and 2G is 100 kilometer per square. Lastly, the first generation 1G is 10 kilometer per square. So giving an example, a single 5G tower can support 1 million IoT device per kilometer per second compared to 4G, which means 10,000 kilometer per second. Now enter the fifth slide. Environmental impacts. Increases energy use in 5G base station consume up to 3 times more energy than 4G. We can see the small image in the right side. The energy using per base station, the 4G is more lower than the 5G. 5G is more higher, around 8.8% than 4G. Denser network deployment, small cell every 100 to 200 meter for millimeter wave coverage. E-waste, frequent equipment update like antenna, routers, modems. The heat emissions and carbon footprint. Telecom sector responsible for 3 to 4% of global energy use. Electromagnetic pollution. Through written safe limits, continuous emission rise public concerns. This all the result is according to Pearson 2020 global mobile traffic growth may cause a 116% rise in ICT power demand by 2013 if not managed efficiently.
I am Shahjahan and I will continue this presentation until the end. In this slide, I will be explaining how smart spectrum management help provide environment suitability in modern communication system. As mobile network continue to expand, efficient use of frequency band become essential, not just for better connectivity but also to reduce energy consumption and environment impact. These are several suitable strategies used in today's 5G networks. First, we have cognitive radio, or we call it CR. This technology allows base station to dynamically detect and use unused frequency band. Instead of keeping channel idle, this system automatically find and switch to available spectrum, which have minimized waste energy. Next, AI-based resource allocation play a major role. Artificial intelligence monitor network demand in real time and adjust power level and bandwidth accordingly. When traffic is high, it boosts performance, but when the traffic is low, it reduces energy use. This ensures the network runs efficiently without unnecessary power consumption. Another key method is sleeping mode, or we call it smart offloading. During off-peak hour, inactive cell or base station automatically power down, conserving energy until they are needed again. This technique can significantly lower overall electricity use. Furthermore, many modern base stations now integrate renewable energy sources such as a solar panel and wind turbine. This hybrid power system make new network more eco-friendly and suitable, especially in remote and rural areas. Finally, spectrum sharing allows multiple network operators to use the same infrastructure. This reduces the need for redundant towers, saving both energy and material, while still ensure broad network coverage. For example, Huawei Green 5G base station use an AI to automatically manage. So next, in this slide, I will be sharing several academic case study and journal insight that have been done by me and my partner to highlight how research around the world are improving the suitability of 5G network. This study show how technology like AI, renewable energy, and cognitive radio are transforming mobile communication into greener and more efficient system. According to Wu and College 2017, 5G network can be made more eco-friendly by integrating renewable power base station. The research emphasized that using solar and wind energy in telecom infrastructure can significantly reduce carbon emissions without affecting network performance. 2. Meanwhile, for Zhang ELT 2019 discussed the trade-off between energy efficiency and spectral efficiency. They point out that while higher frequency offer faster data rate, but they also consume more power. So it's important to find a balance between performance and suitability. Purvis and College 2022 and 2030 propose a new energy paradigms for future mobile network. They recommend using AI driver control system and slim-on that automatically power down unused cell, which help lower energy consumption during low network activity. In other study, Ezadai 2024 explore how artificial intelligence can further improve efficiency. Their findings show that AI can predict network load in real time and adjust energy use proactively, avoid unnecessary power drain, and improve sustainability. Lastly, Ali 2023 focus on cognitive spectrum management, which use smart sensing to identify unused frequency. By detecting and relocating spectrum dynamically, this approach helps prevent idle energy waste and optimize overall network operation. A real-world example of this principle in action can be seen in Finland, where 5G tower powered by wind and solar energy achieve a 30% reduce in CO2 emission compared to traditional grid power site. This clearly show how suitable a network design can make a measurable environmental impact. This study collective highlight that the future of mobile communication depend not only faster data speed, but also on smart energy consumption technology that help protect our Earth. Together, these innovations form the foundations of truly green and suitable 5G and beyond. And future outlook. The expansion of operating frequency from 1G to 5G have been vital in supporting the rapid growth of global digital connectivity. However, this progress brings higher energy consumption and environmental challenges led to increased infrastructure and material use. By adapting efficient spectrum management and smart network optimizations, the overall carbon footprint can be significantly reduced. Moving forward, the focus will be shift toward green 6G network that are carbon neutral, AI driven, and powered by renewable energy. For instance, a recent Green Future Network initiative target an 18% reduce in energy consumption per gigabyte by 2030, marking a major step towards sustainable mobile communication. In this slide, I provide it specially and more detail about the journal me and my partner have been referenced about. So here is the 5 journals we are using. The presentation has come to the end. Thank you for your time and attention. So I will remember it again. This presentation highlights the importance of spectrum expansion from 1G to 5G and the need for sustainable energy efficient network development toward a green 6G future. Together, innovation and responsibility can create a connected world that is faster, smarter, and environmentally sustainable. This slide and this presentation prepared by me, Shah Jehan, and my partner Wong Li Wei. We are from DEP5B Polytechnic on Khor Ma.